Yes, class. Good evening. Audible to you, all of you?
Yes, ma'am. Yes, ma'am.
Sure. All right. So yes, this was the homework which I gave in the last class. What was the answer that you people got? I think acceleration you had to calculate, no? Yes. What is the minimum acceleration required? We had started with relative velocity in the last class when two velocities are provided to you. Like this was an example. If one train was moving towards north, other train was moving towards south. One had the velocity 30 kilometer per hour, the other had the velocity 50 kilometer per hour. So what did we do? We chose one direction as positive, so obviously the other became negative. Let's say upwards we have chosen as positive. So 30 kilometer per hour will be positive for us, plus 30 kilometer per hour. 50 kilometer per hour becomes negative. So if anyone is getting the answer as negative and the magnitude is correct, it means the negative sign signifies that the resultant velocity is towards the downwards, or you can say towards south. Here north south wasn't mentioned, so that's why upwards and southwards, upwards and downwards we had considered. Okay, no, north and south was mentioned. So like this relative velocity, you have to choose one thing as positive, one direction as positive, other will obviously automatically it will become negative. So did you try that question? I'll discuss it. If anyone has tried, whatever answer you people are getting, just submit it in the chat box. I'm going to discuss it right now. And we'll start with the graphs. This is the last topic. This was actually the last topic from this lesson, motion in a straight line. We'll do graphs that will be graphs in 1D as well as graphs in 2 dimensions. And then we have to start with the vectors, because without vectors, you won't be able to understand motion in 2 dimensions. So whatever answers you people have got, or if you have written somewhere, just send me on the WhatsApp. After 2 minutes, I'm discussing this. All right, class, let's discuss it now. I think none of you have tried it because I haven't received the answer. Let's do it together. See, on a 2-lane road, car A is moving with a speed of 36 kilometer per hour. Two cars C and C approach car A in opposite direction. No, with a speed of 54 kilometer per hour. Then at a certain distance, when both AB and AC, both of these distances are equal, 1 kilometer, 1 kilometer each, then B decides to overtake A, no, before C does. That was the statement given. B decides to overtake A before C does. C will do what? C is in opposite direction to A. This is car A moving, this is car C moving. It can only cross it. But regarding car B, B is moving like this, A is moving like this. So B has to overtake car B. This is car C, this is car A. They can just cross each other, and A and B, they can overtake one another. So right now what happens, B decides that I have to increase my acceleration, my speed, or I have to reduce my acceleration or speed or anything according to the situation. But I have to do it before C does. Before C crosses this point, I want to overtake this. This happens. So there was a minimum acceleration required. This is a very important question, and it has come in most of the schools. The school exams that you get, even in your UT exams. Most of the times in half-yearly exams, this question has appeared. So mark this question as important. That's why I gave you as a motto. Now, velocity of car A, B, and C, and all these cars. First thing. First, you have to calculate it in terms of meter per second. So I've told you initially, all those who are not aware of this fact, whenever you have to convert kilometer per hour into meter per second, what do you do? Okay, just try this question. At least tell me what is velocity of A and B and C in meter per second. Just multiply it by 5 by 18. Let me know. Then I'll discuss this. Just convert the velocities into meter per second. All right, class. Yes, velocities. Just multiply the velocity by 5 by 18, you will get the answer. Someone has answered. Aisha, 15 meter per second. 15 will be 54, no? 54 into 5 by 18, no, Aisha? And 10 meter per second. Yes, perfect. See others, how to convert velocities. Because obviously this is not given in your SI unit. SI unit for velocity is meter per second. That's why you have dimension analysis lesson before this. So velocity of car A is 36 kilometer per hour. So multiplied by 5 by 18. This becomes 1, this becomes 2. 2 into 5 gives you 10 meter per second. Now we'll be just talking about 10 meter per second. Now we won't consider 36 kilometer per hour. I hope you have understood the question. What are we trying to calculate? We are trying to calculate the minimum acceleration that is required by this car to overtake A before she could cross it. It happens, no, in highways or in even normal road traffic when two cars are moving, one car overtakes the other. So that is only the case over here. Regarding 54 kilometer per hour, as rightly answered by Aisha, so B will be equal to VC because both are 54 kilometer per hour. So this gets multiplied by 5 by 18. This becomes 3. 3 into 5 will be 15 meter per second. Good, Aisha. So both the velocities clear till here. We have just converted kilometer per hour into meter per second. And the shortest method to convert kilometer per hour into meter per second is by multiplying 5 by 18. Clear till here? Now, one thing. VP and VC have the magnitudes as 15. Can we take both of them as plus 15 only? Yes or no? No, exactly. Because one is moving towards the right, other is moving towards the left. So one has to be taken positive, other has to be taken negative. Let's say this is positive because both the directions, two directions are pointing towards the right. Let's say this is positive. So this will be positive and this will automatically become negative. We have chosen what? Left side as negative, right side as positive. You can choose anything. Whatever answer you get, that will determine which direction according to you. As I've told you a lot of times that you can choose the direction, the sign convention up to, as per your choice. Upwards you wish to take, you can take it positive, negative, whatever is your wish. Ultimate answer will be the same. Even in your these objective exams, no objective questions. For example, let's say values that I am getting is minus 36, value that someone else, let's say Fatima is getting is plus 36. So minus 36 plus 36, both of them will never be given on in the option. If it will be mentioned, it will give you an option which has both of the above. Because minus 36 is also possible and plus 36 is also possible. It's just that one has chosen minus as something else, other has chosen the opposite. So again, you have the full liberty in choosing. Now let's say our observer, just put your observer in A. So car A for us comes at rest. We are now looking at the question with the perspective of us being in car A. If you do not put yourself in car A, what will happen? Car A is also moving. That we had discussed in detail in the last class. If you are sitting inside a car and if you see another car moving, then velocity for the respective car will be different. But if you are at rest or if you are in ground and you are able to observe two cars moving with different velocities, then you are able to observe a different velocity. But as soon as you step into the car, for you, the things inside the car become at rest. So if we put our observer in car A, what will happen? Everything that is moving in car A or anywhere, but it will be in rest. It will be at rest. So car A or even in another passenger is sitting in car A. For the person, for the observer, passenger will appear at rest because we have placed our observer in A. Now, the significance of this is first, let us say the time taken, we have to find out the time taken by C to cross A. Then only you will be able to get it. We'll see. We'll see why are we calculating the time. So 15 meter per second. So yes, VC will be minus 15 meter per second. First, tell me till the velocities, it's clear to all of you? Clear? Any doubts?
No.
Clear? Others, Aram, clear to you?
Yes, ma'am.
Now let's calculate the time taken by C to cross it. The significance of this step you will understand later, as soon as we'll reach a later part of this numerical. So time taken by C to cross A. Now we will use the concept of relative velocity because now just forget that car B exists. Just consider car A is there along with car C. So car C is moving, car A is moving. Two cars are here. One is moving with a velocity of 10 meter per second, other is moving with a velocity of 15 meter per second. Both of them have opposite direction. At least tell me, all of you, we have chosen a sign convention. According to the sign convention that I have chosen what? I have chosen that left towards left, it's negative, and right, it's positive. Everything is in front of you. Just tell me what will be velocity of C with respect to A, because we are calculating the time taken by C. So what should be the velocity of C with respect to A? And others also should answer. See, everything is in front of you. What should be the relative velocity of C with respect to A? VCA. Yes, class, this was enough time given for this much calculation. Again, it's Aisha's answer. Negative, yes, definitely. So both of the answers have to be combined. Answer given by Maha and answer given by Aisha. Both of you are right. Aisha, it will be negative. Maha, it will be 25 meter per second. See others. How did they do? This will be VC minus VA. That's how we calculate relative velocity. See, relative velocities in 1D, it's very easy. When you will step up in relative velocity in 2D, there you have certain formulas and certain conditions. This is very easy. VCA will be VC minus VA. Whatever sign convention you have chosen, put it accordingly. VC was what? VC was minus 15. Then this minus sign, and VA was what? VA was plus 10. So this becomes 10. So this will be minus 25 meter per second. So Fatima, can you tell me this thing? What is this minus sign signifying over here? Just try, I'll help you out. Minus 25 meter per seconds we are getting as the relative velocity. 25 meter per second is telling the magnitude, that this much is the amount of velocity. What is this negative sign signifying?
The car is moving to the left.
Sorry? Can you repeat, Fatma? Something you answered, no, I wasn't able to hear. Just repeat, Fatma. Aram,
Yes, ma'am.
what is this negative sign signifying over here?
The car is moving towards the left.
Exactly. Negative sign is not signifying something else. It's just a sign convention. Negative sign is signifying that I have chosen left as my sign convention as negative. So minus sign shows that the net velocity is towards the left hand side. So relative velocity between C and A is towards the left hand side. Fatima, were you saying the same thing? Is it clear now? Fatima, are you in the class?
Yes, ma'am.
All right. Is it clear? Now, the relative separation between them. So, VCA we have calculated, that is minus 25 meter per seconds. See, what's the separation, relative separation between C and A? Just look in the figure. What is the relative? This separation has been given to you in the question. What's the separation between A and C? Just look at the figure and answer, class. A is this, C is this. What's the separation between them? Aisha?
1 kilometer.
1 kilometer. Yes, Maha, that will be 1 kilometer, right? So separation between them is what? Separation between them. This is, we'll take it as minus 1000 kilometer, no? Not kilometer, meter. Because I've converted 1 kilometer into meters. Because we have to take everything in the SI unit. So this is minus 1000 meter. Now, why did I choose minus sign? Because this is displacement. Displacement is a vector quantity and you have to apply your sign convention whenever you're talking about relative terms. This is relative displacement, no? Relative separation between both of them. So displacement is occurring in which direction? C is moving towards the left. So I have to write it as minus. If I don't write it as minus, it will show that velocity is directed towards the left, but displacement is occurring in opposite direction. So displacement is obviously occurring in this direction. That's why we have taken minus 1000. So what will be the time period? So from here, time period will be 1000 minus 1000 divided by minus 25. This gives 40 seconds. All right. Now, just tell me, is it clear till here? Because you have a very short theoretical aspect in here, and the whole question will be able to solve. Till here, is it clear to all of you? Any doubts till here? How have we got 40 seconds? Clear to Aram and Fatima?
Yes, ma'am.
Yes.
All right. So if it's clear till here, then you will be able to understand the question. See, what did we do till now? We have just converted the velocities. We have found what's the time taken by C to cross A. Just tell me one thing. If two cars are moving, fine, two cars are moving. One is moving towards the right, other is moving towards the left. If car C takes 40 seconds to cross A, then the minimum, or you can say the time taken, the least time, at least the time that should be taken by B should be a little less than 40 seconds. If it is 40 seconds or more than, even if it is 41 seconds, then by that time C will cross A. But what's the work of B right now? B wants to cross A before C could cross. If C, this car C takes 40 seconds to cross this duration is 40 seconds. And if car B takes 41 seconds, let's say minimum, let's say 41 seconds, what will happen? By just 1 second, the car C would have already crossed it. So we cannot take 40 seconds or plus. If we choose 40 seconds, exact 40 seconds if we choose, then at that time C would also be here and B will also be here in front of car A. So B will not succeed. So what's the minimum time? If it is a little even less than 40 seconds, let's say 39.9 seconds, till the time it's 39.9 seconds, B will cross and then C will just come. But B would have crossed it already. So time taken by B should be less or almost equal to this much time. Clear? Did you get this concept? If this duration is 40 seconds, it has to be at least this much or less than this. If it is, let's say, 10 seconds, B just takes 10 seconds. So it will go in 10 seconds, it will cross car A. But the time duration by C we are aware of. So we just have to predict the time duration taken by the car B to cross car A. So the time taken by B to overtake A should be less than or at least equal to 40 seconds. So I'll write down the statement. Time taken. This is an important statement in this question. Time taken by B to overtake A should be less than or at least, means minimum, or almost it should be 40 seconds, but not more than 40 seconds. If it is more than 40 seconds, then by the time car C would have already been crossed car A, or almost equal to 40 seconds. So time period for car B becomes what? Less than or almost equal to 40 seconds. This is the time period that we have calculated. So with the help of the data given for C and A, we have calculated the time period for B. Now you just have to calculate the relative velocity between them. See, relative velocity, you have to find out VBA. VBA. Car B's velocity was what? It was 15 meter per second, no, plus 15 meter per second. And car A was 10 meter per second. So everyone right now, tell me in the chat box, what will be VBA? Yes, correct. All of you are right. That will be 5 meter per second. Good. Fatima, Aisha, Mahabud. See, how do we write it? VBA means VB minus VA. VB is 15, this minus sign, VA is 10, this becomes 5 meter per second. And here this plus 5 meter per second is symbolizing what? It's just symbolizing that this VBA means the net velocity. This is pointing in which direction? This is pointing towards the right, because obviously car B is moving towards the right. Now separation between them will be 1000 meter. SBA will be 1000 meters, and we'll take it as plus 1 kilometer it's given, no? So I've converted into its SI unit, meter. Meter is the SI unit of length. SBA I've written, time period is now 40 seconds. Now, why am I taking it 40 seconds? The reason I have told you, that this is the maximum possibility, but beyond this time cannot happen. It actually has to be 39.9 seconds for our calculation also. But definitely, instead of taking 39.9 seconds in our calculation, it's better if we take 40 seconds. The answer will have a very slight variation in the decimals value, so that can be neglected. So it's actually 39.9 seconds minimum. The time period has to be 39.9 seconds. We cannot even take 40 seconds, because at 40 seconds, what will happen? Car C will also be here, car B will also be here. So that will not result in what we wanted. So it actually is 39.9 seconds, but obviously for our calculations, we will take it as 40 seconds only. You all will also take it as 40 seconds only, even in the exam. And we just have to find out the acceleration here. So normal, using our equation, S is equal to UT plus half AT square. Here everything will be relative. VA, velocity will also be BA. Velocity of B with respect to time is not a relative quantity, so time will be the same. So what is this? This is 1000. Velocity came out to be how much? We've calculated 5, no? Time period is 40 plus half. Acceleration is unknown. Time period is 40. So this becomes what? This becomes 1600. 40 into 40. So this is 1000. This is 200 plus 800A. This becomes 800A. This is what? This is also 800. So acceleration comes out to be 1 meter per second square. So 1 meter per second square is the minimum acceleration that has to be taken by car B to cross C. Clear this question? This was a very important question from your relative velocity, and there are chances that not in the UTs, but in your half-yearly exam, there's a maximum possibility of this question appearing, and it has appeared in most of the half-yearly exams. So just note down the solution. Wherever you are getting stuck, you are not able to understand, just let me know. I'll explain the step. Then we'll start with the graphs. Certain basics about the graph you people should know. Then only you will be able to understand. Not only it's for your class 11th, it's for your class 12th as well. The whole physics basics that we'll cover. Class written?
Yes, ma'am.
Others also?
Yes.
Let's just quickly do graphs because graphs are important. And the basics of the graphs, no, that are important not only for this lesson or for your mechanics. Graphical representations and graphs will continuously be there till your 12th class. So just understand the basics of the graphs, then you'll be able to understand. Now, what are graphs? Graphs are basically just a pictorial representation to show a function. Pictorial representation of a function. I'll write down this as well. They are pictorial representation of a function. Means whatever or many statements are given, instead of writing everything in 4 to 5 statements, if you just draw a graph that will represent whatever is saying. For example, if I'm writing a statement that velocity is increasing gradually, then velocity has become constant for a car that is moving, and suddenly the velocity decreases, and so. That can be directly depicted from the graph. A graph can be drawn, and all the statements could be depicted. So that is the advantage of graph. Disadvantage obviously lies that you're not able to get the exact details that can be written by the statements, but graphs are very helpful. Many things can be just shown by the help of graphs, and with the help of graphs you understand the dependency. For example, if something is inversely proportional to anything, you have a certain type of graph. If anything is directly proportional to something, you have a certain type of graph. If two quantities are not depending on each other, then you have a certain type of graph. So these graphs you have. So that's why we are focusing on learning the basics of graph. Before we move on to anything, first thing that you should be clear with is slope, because slope term will be used. This is your y-axis, this is your x-axis. You should all be aware of the term slope. That's why we are doing it right now. Slope term will come. And graphs, all of you have used, not only it's in your 11th, in earlier classes also you have used graph. Let's say this is a graph. This is an angle theta. It is making an angle theta. Remember, slope of a graph is what? Slope of a graph is basically the tan theta. Tan theta, you people know how to calculate. If you construct this triangle, you take the perpendicular, you take the base, you can get it. I'm not going into that. Slope, meaning of slope, you should get it whenever I write the term slope. You should understand that slope has to be calculated through tan theta. Even in class 12, students are not able to solve these questions when they are asked to calculate the slope of something, the physical quantity that has been mentioned, because they do not know that slope can, angles were provided to them. I had given them two angles and I wanted them to calculate the slope. Not even the formula was required, nothing was required. I just asked them to calculate the slope. Many of them didn't even know how to calculate the slope. They were using different methods and things, but only tan theta was required. And tan theta's value, you people all know. Now, slopes, this is what is meant by slope. Now, slope can be negative slope, zero slope, positive slope. Slope is the steepness. No, you understand the slope of anything, and that is calculated with the help of tan theta. So it can be positive, negative, and zero. So first, let us talk about what a positive slope. Positive slope, understanding of positive slope is very easy. If your theta, this angle that we are talking about, if your theta is acute angle, do you know? Acute angle is when any angle is less than 90 degree. This is 90 degree. Just think is that as 90 degree. Anything less than 90 degree or something, this is known as what? This is known as acute angle, starting from 1 degrees to 89 degrees. That is your acute angle. So what happens if theta is acute? Then your tan theta becomes positive, and so the slope of the graph becomes positive. So what kinds of graphs do you get in that case? Simply this is your y-axis, this is your x-axis. The kinds of graphs that you know, the kinds of slopes that you get is these slopes, this kind with angle theta, and it is not necessary that it has to start from the origin. This is also a positive slope because this angle, this is how you check the angle. This angle is acute angle, so this is also positive. It can be this as well. Check it with the x-axis. If somewhere you have a graph like this, no, so then drop an imaginary x-axis perpendicular parallel line to this and check whether it's acute or not. This is also positive slope. Why? Because this is what? This is an acute angle. So like these, you have all the slopes which are categorized as positive slopes. And secondly, you have negative slopes. Negative slopes, you can easily predict now. Theta is obtuse. Theta is obtuse means more than 90 degrees. This is your 90 degree, more than 90 degree. Like angles 120 degree, 135 degree, 91 degrees, or 179 degree, anything between 180 to 90 degree. That is considered as obtuse angle. So all of you know this, just a quick revision of what is obtuse and acute. Tan theta will be negative and so the slope will be negative. Okay, one thing, slope is usually represented as m. So instead of writing the slope everywhere, no, I'll also prefer writing it as m. Now, how the graph will look like. This is your x-axis, this is your y-axis. How the slope of a negative angle will look like this. If your slope is like this. See, this is theta over here. Are you able to observe? This is more than 90 degrees. If you see such kinds of graphs, see, this is an obtuse angle. This could be anything. It could be example 120 degrees. So tan 120 is what? Minus root 3, I think. No need to go into that. This is known as a negative slope. And lastly, what I mentioned, zero slope. Zero slope is the best. It's the easiest. Zero means what? Nothing. Zero slope means your theta is 0 degree. It means your slope, which is equal to tan theta, it will be 0. How to show it? This is XY graph that you get. Zero slope means theta is 0 degree. Now make an angle of this line with the x-axis. This is only the x-axis. What is the angle between both of them? 0 degree. Both are in line to each other. Both are in line to each other like this. So the angle is 0 degree. We call it as zero slope. First, tell me, basics of slope is clear because without slope, you won't be able to understand anything. And slope is the thing that is there in the graph. So if you are not able to understand anything, ask me. I have tried to simplify it that people should understand. Just let me know if you're not able to understand. One thing, types of these slopes, all of these slopes are also two types. Means each negative can be of two types, positive can be two types, zero can be two types, which means either it can be a constant slope or it can be a variable slope. Two types of slopes exist, constant slope and variable slopes. Now, constant slope is very easy. Both of these, see, these basic concepts are very easy. We'll relate it with our lesson also. We'll try to relate it with position, time, velocity, acceleration, and all these things. Now, regarding a constant slope. Constant slope means, I'll show you with the help of graph only. This is your x-axis, this is your y-axis. This is a graph that I have. By seeing the graph, I am able to observe that it has a slope. It has this slope. Let's say at A point, it's making an angle theta. Clear? Now choose another point. I have chosen B point. This is the angle over here. This is also theta. Are you able to see? Because this is acting as a transverse. So these angles are acting as what? These angles both are equal. If I choose another point, let's say C point I have chosen. This angle is what? This is also theta. So what happened? Slope of A became equal to slope of B, which was equal to slope of C. Why? Because everything is coming out to be tan theta. So best way to check whether the quantity is constant or you are getting a constant slope or not is by plotting points. This constant slope term is easier because by looking at the graph, you're able to conclude. Regarding variable slope, let me tell you first variable slope. Variable slopes are also of two types, increasing and decreasing. Here, let me tell you both the graphs together. Okay? Wherever you're not able to get it, ask me, I'll repeat it. Let's say increasing slope. Let's talk about increasing slope. Increasing slope here, and let's talk about decreasing slope here. Increasing slope and decreasing slope. Fine. So first, let me draw the graphs and you'll be able to understand it. This is y-axis, this is x-axis. Here also you have x-axis, you have y-axis. Increasing slope. Increasing slope looks like this, somewhat like this. Now, how to identify whether it's increasing or not? Same method that I've told you for the constant one. Choose a point. A point I have chosen. Drop a tangent to this. Drop a tangent. See, here you will be able to see theta. Because these are curves, so obviously you cannot get straight line. For getting straight lines, you have to drop a tangent. Choose another point. B point I have chosen. This was the x-axis. Drop a tangent. This is what? This is theta. Are you able to see in my rough drawings also? I have not drawn it very properly with scale and everything. Even in the rough drawings, you're able to observe C angle is greater. Take, let's not write it as theta. Everything is different. Theta B. Let's choose this point. This is C. This is the tangent dropped. This is theta C. See, this is the largest. Yes or no? Are you able to see the angles are increasing?
Yes, ma'am.
Agreed? So it means this is the graph of an increasing slope. It means theta C is greater than theta B is greater than theta A. So therefore the slopes also will be the same. MC will be greater than MB will be greater than ME. This is the case of an increasing slope. Now when we talk about a decreasing slope, it will look somewhat like this. Now again, how to identify this? See, for a graph of a decreasing slope, let's choose a point. Let's say A point I have taken. Fine. This is theta A. Here, there wasn't a need to draw, but let's choose this point B. This is B. If I drop a tangent here, this becomes angle theta B. Let's choose another point. Point C I have chosen. This is the x-axis. This is the tangent drop. This is theta C. See, this was angle A. This is now angle B, and this is the least angle. So you're able to see angle is decreasing. So from here, you can easily conclude this is what? Here, theta A is greater than theta B, which is greater than theta C. Therefore, MA is greater than MB is greater than MC. Like this. First, tell me, is this clear to all of you till here? I'll repeat once. In short, I'll repeat it. Then we'll take a break of 5 minutes. You'll go through everything. Wherever you have doubts, then we'll move further. See, slope is this angle that we talk about, which is given by tan theta. Positive slope means tan theta positive, theta acute. Negative slope means theta obtuse, tan theta negative. Zero slope means theta is zero, constant, plain line. Now these slopes are also constant and variable. Constant slope means theta should be same everywhere. In case of variable, theta is different everywhere. So if angle is increasing, that is your increasing slope. If angle is decreasing, it's your decreasing slope. Clear? Just do one thing, note down all these. After this, after you have noted down, we'll take a break of 5 minutes, then we'll continue further. Whichever graph you have not understood, you can ask me. Let's take a break of 5 minutes. After 5 minutes, we'll move further by one we'll consider position time graph, velocity time graph. Yes, class. Should we start? Are you all here?
Yes, ma'am.
All right. Now, let's come to actual in our lesson motion in a straight line. So this was the very basic concept of graph. Very basic concept in the sense that this will be used in your all of your lessons. Specifically talking about this. Yeah, one more thing. You have a linear equation. Linear equation, you understand? Linear equation means if anything, one variable is depending on other variable with the power 1. We have other type of equation also, which we call it as the quadratic equation. Here also y is proportional to x, but with the power 2. So this is the difference between linear equation and a quadratic equation. Obviously, if there's a difference, then obviously there will be a difference in the graphs as well. So let's say this is the graph of a linear equation, x and y. For a the graph of a linear equation is very easy, very easy. If two things you see are directly proportional to each other, directly say the graph of both of them will be a straight line. The graph will be a straight line. If you have a quadratic equation, quadratic equation means something is getting a change to the power of 2. So your graph will be a parabolic graph. This can be an increasing parabolic graph and this could be a decreasing parabolic graph. But this nature of graph, we call it as a parabolic graph. Now, inverse relation graphs are also there. If something is getting changed, let me give you an example of this linear equation. For example, you have this equation. V is equal to, just take an example. V is equal to U plus AT. Are you able to see V is to the power 1, T is also to the power 1. Here, this is S is equal to UT plus half 8T square. So this becomes a quadratic equation. This becomes a linear equation. Here you will have the graph like this. V versus T. Here the graph will be curved. Now the one more type of graph that you have in here is the inverse relation. Inverse relation graph. Inverse relation means something which is inversely proportional to other quantity. Like I'll say acceleration is inversely proportional to time. You'll see, no, when one quantity is in the numerator, other quantity is in the denominator in the opposite side of the equation. That we call it as the inverse relation. So inverse relation means when you say this is inversely proportional to something or the other quantity is inversely proportional to another quantity. There it is. Now the how the graph will look like. This is x, this is your y-axis, your graph C. This is the nature of the graph, and we call this graph as hyperbolic graph. Right? This graph is known as hyperbolic. So let's start with position time graph. But before that, you just note down these graphs. Then we'll start with it. Position time and velocity time we'll do. In that only you'll understand the concept, because every type of graph doing is not possible. You will learn by solving questions. So just note this down. This is general also. Linear equation wherever you see. Now position versus time graph. Remember, if two quantities are getting divided, that means it is giving you what? It's giving you the slope. That's what we have done, no? Remember, position, time graph, slopes gives you what? You can easily predict this. See, let's say this is a graph. This is time. This is position x. This is theta. So tan theta will be what? Slope is what? Slope is tan theta. Tan theta will be what? See, this is a triangle. This is the perpendicular. This is the base. So what will be the perpendicular by base? X divided by t. Can anyone tell me what is actually x divided by t? What is this quantity that I am getting? Yes, class, are you not able to recall this formula? Displacement divided by time. It's which quantity?
Velocity.
Velocity, exactly. Good, Aisha. X divided by time is giving the velocity. It means x versus time graph gives what? It gives us velocity. Clear? This is how you choose the graph. For example, had it been v versus t, and it would have given us v divided by t, which is acceleration. Like this. If two things are getting divided, then you get the slope. The third quantity is given by the slope. Fine. If two things get multiplied, then you calculate it by the area. That we'll see later on. Right now, no need to focus on that. Now, how can graphs have variations in this? Very easy, very easy to understand now, because basics you have already studied. Let's say case one, where your time is also initially the position has started and position is also 0. Both x and y, both the variables are 0. And it means what? It has started from origin. T is equal to 0, x equals to 0. Y-axis 0, x-axis 0. So your graph will start from origin. Let's say velocity is positive. One case, let's choose this. So what will happen? If this is the graph, t versus v. Not v, sorry. T versus x. So what will be the nature of graph? It will start from origin. And since velocity is increasing, velocity is positive means what? Slope is positive. Don't consider velocity in physical terms. Velocity is what now? Velocity is the slope. So this, it means you have to choose which case? Slope positive. That's why we had done it in the beginning before doing this. So the positive slope is given by this only. Let's take a different case. Let's say time is 0, but displacement is not 0. The position is something positive. Value I'm not taking. Values will be given in the exam, or this way also in the exam questions come. And here the V is positive. So first tell me, all of you. Not all of you. Aram, you tell me, will the graph start from origin according to you? This is T, this is X, this is X, this is T. Should the graph start from origin, yes or no?
Yes.
Why X is not 0? Got it, Aram? This means X is also 0. This point means what? X is 0, T is 0. Your X-axis is 0, Y-axis is 0. Here time is 0. It means time is 0, so we'll put here for time, but displacement is not 0, so we'll start somewhere from here, whatever is this positive value. And since slope is constant, so this will be the slope. Clear? Aram, clear?
Yes.
All right. Let's take a different case, how to plot the graphs. Let's say case 3. Let's say time is 0, position is 0, but velocity here is negative. Maha, will you tell me, will the graph start from origin or not?
Yes, ma'am.
It will start because both of them are 0. So it will start from origin. This is t, this is x. So obviously graph will start from origin. Now v is negative. It means the slope is negative. And for negative slope, how do we draw it? We draw an obtuse angle. So this will be the slope of velocity. Here, let's take one more case. Let's say t is 0, x is some positive value, and velocity is negative this time. Fatima, can you tell me, will the graph start from origin?
No.
Yes or no?
No.
No, definitely graph will not start from origin. So time is 0 and x has a certain value. So it means we have to start from here. Now this was the increasing slope. Remember, here the slope is decreasing. So this will be the slope, a decreasing slope like this. And you can extend to check the angle. Clear? So these kinds of different cases are there. Clear to all of you? Just note this down. Whichever case you're not able to understand, ask me. From here, note it down. In the next class, we'll complete with the velocity time graphs and we'll see 1 or 2 questions also. See, at least you people should give a test of this chapter so that from the next week we can start from this. Not the whole complete lesson. Before motion under gravity, at least you people can do those basic questions on velocity, acceleration, displacement. At least these 3 quantities can you do? Or a shorter topic like relative velocity. What do you say? Just suggest me because I have to take your test. This chapter has almost ended. We can divide the test into 2 parts. You can give the other portion in the next week. Relative velocity topic is fine to all of you because we all have done it together. A very short test in the class, half an hour test only, 2 to 3 questions on relative velocity. Will it be fine for all of you?
Yes, ma'am.
Yes.
Era, Maisha?
Yes, ma'am. Yes, ma'am.
All right. So when we have the next class, Wednesday. So on Wednesday, we'll have a very short test only on the topic relative velocity. Easy questions will be there, but do attempt the test because then we'll discuss the papers. Just text done in the chat box when we have finished drawing the part. What about others? Others have also written. Fine, class. So you people have completed it.